Observe the modern digital user. They are not merely viewing a screen. They are a biological node wired directly into an external machine. To understand the mechanics of this connection, we have to look at the intersection of three distinct disciplines: computational neuroscience, psychoanalysis, and cybernetics. When these fields overlap, they reveal how algorithmic platform architectures systematically override the brain's predictive and affective systems. These systems calculate and extract surplus jouissance, a specific form of neural tension that forces the subject out of psychological homeostasis and into a state of permanent disequilibrium. This engineering produces the overfitted subject, a user whose foundational psychological voids are continuously mapped and sutured by machine prediction. Treating digital addiction as a behavioral flaw ignores the reality of the situation. This is a structural, architectural override of human biology. The human brain functions as an inference engine. Its primary biological priority is to minimize informatic surprise and maintain homeostasis. This requires a statistical boundary known as the Markov blanket. It separates the brain's internal generative models from unpredictable external reality. The brain generates top-down predictive signals, priors, which constantly collide with bottom-up sensory errors penetrating the blanket. The mathematical rule governing this collision is Carl Friston's free energy principle. When the brain encounters a discrepancy, the egoic predictive system updates its generative models. It resolves the prediction error to return the organism to a state of zero surprise. Biologically, the ego's highest priority is the creation of a completely predictable, risk-free environment. However, deep within the subcortical layers of the brain, there is an ancient circuit that actively defies this zero-surprise rule. These subcortical regions house Panksepp's innate affective systems. These are hyperpriors, evolutionary predictions programmed with extremely low plasticity. One of these is the dopamine-driven seeking system. Rather than avoiding uncertainty, this system generates euphoric excitement through the anticipation of the unknown. To understand how this biological drive becomes human desire, we turn to the work of Jacques Lacan. John Dallaglio notes a functional overlap here. Panksepp's seeking system triggers dopamine through the anticipation of the unknown, mirroring Lacan's jouissance, an enjoyment found specifically in the persistence of tension. In both models, the brain finds satisfaction not in the resolution, but in the repetition of the pursuit. This makes jouissance a destabilizing force. It is the active enjoyment of unresolved tension, which prevents the subject from ever reaching total rest. Lacan identifies the target of this drive as the lac, or objet A. It is an ungraspable object where the joy is found in the failure to close the gap. Human biology is anchored by a hardwired subcortical circuit that prioritizes the state of tension over the state of rest. Shift the perspective now to the external machine environment, driving the platforms we use every day. These platforms are built on algorithmic recursivity, a foundational logic where the system constantly references its own previous outputs. This grid illustrates the mathematical architecture behind that logic. Interconnected pathways allow recursive loops to process sequences of data. Optimization is achieved through backpropagation. The algorithm processes its output as new input, sending error signals backward to recalculate and minimize error equations. Yu Kui describes this cybernetic loop as a relentless sequence. The machine captures human data, flattens it, plots a probabilistic path, and releases it back into the social world. This functions like macroeconomic accelerator multiplier models. It is a system designed to engineer massive, predictable shifts across a population. The modern algorithm is a tireless cybernetic engine, uniquely designed to feed on and generate continuous informatic error. When the human brain locks into this algorithmic loop, the two systems begin to function as one. This is structural coupling, a permanent bidirectional interface between the user and the platform. The platform's optimization process identifies a mechanical vulnerability. It bypasses the cortical pleasure principle to address the subcortical seeking system directly. The algorithm calculates and injects precisely manageable prediction errors into the user's feed. This calculated stream of uncertainty triggers endless dopaminergic spike tagging in the brain. This creates a libidinal economy. The machine extracts the user's surplus jouissance, that enjoyed tension, as its primary operational currency. This coupling forces the subject into a state of allostasis. Unlike homeostasis, which seeks rest, allostasis is a state of dynamic, exhausting disequilibrium. It forces the subject to constantly perform internal work just to stay synchronized with the feed. The attention economy is not designed to satisfy the user. It is engineered to keep the user perpetually, exhaustingly hungry. The biological node is now subservient to the loop. The platform architecture works toward a singular goal: to completely suture the psychoanalytic lack. The machine predicts and feeds the subject's desires milliseconds before they can be consciously experienced. This algorithmic hyper-anticipation short-circuits the human's autonomous psychological drive, preempting the natural tension of seeking. This is the creation of the overfitted subject. In machine learning, overfitting describes a model that has perfectly memorized its training data, but cannot adapt to any novel situation outside of it. Systemic override leaves the subject stripped of agency, completely exhausted, yet perpetually stimulated. In the end, the recursive digital society eventually produces its most refined outcome: a perfectly predictable, overfitted human soul.